You know how sometimes you need to scale a recipe for more people, or mix the perfect shade of paint, or figure out the best deal at the grocery store? Well, the secret to all of that isn't some crazy complicated math. It's a super powerful tool you're probably already using without even realizing it. It's the ratio. And today, we're going to pull back the curtain and show you how to master it. Okay, let's just dive right in with a real-world puzzle. So, the perfect drink recipe calls for a 1:4 ratio of cordial to water. You've got exactly 100 milliliters of cordial sitting on the counter. The question is, what's the total amount of perfect drink you can whip up? Stick with me, because we're going to solve this thing step by step. Now, looking at this problem, I know what you might be thinking. Your brain immediately wants to start adding or dividing stuff. But hold on. To actually get the right answer, we first need to get a handle on the simple rules that make ratios work in the first place. So, let's break it all down. Once you really get these fundamental building blocks, I promise, everything else is just gonna click right into place. So, what even is a ratio? Well, at its heart, it's really just a way to compare things. Think about mixing paint. If you use, say, 2 parts blue for every 3 parts yellow, your ratio is 2 to 3. It's that simple. It's like a recipe for the relationship between those two things. And here is maybe the single most important rule you need to remember. With ratios, order is everything. I mean, 2 parts blue to 3 parts yellow gives you one specific shade of green. But if you flip that to 3 to 2, you're making a completely different color. The order tells the whole story. You know, just like fractions, you can often simplify ratios to make them way easier to work with. Let's say a class has 12 girls and 15 boys. That's a 12 to 15 ratio. To simplify it, we just find the biggest number that goes into both sides, which, in this case, is 3. Divide both by 3, and you get the much simpler ratio of 4 to 5. So for every 4 girls, there are 5 boys. So much cleaner, right? Okay, so now that we've got the basics down, you need to know that there are really only 2 main ways to solve pretty much any ratio problem. And the real secret isn't just learning the methods, it's knowing when to use each one. Let's break them down. First up, we have the sharing method. You'll use this one whenever you have a total amount that you need to split up. For example, let's say you're splitting 140 pounds in a 3 to 4 ratio. The very first thing you do is add the parts together to see how many there are in total. So 3 plus 4 is 7 total parts. Then you divide your total amount, that's 140 pounds, by those 7 parts. That tells you each part is worth 20 pounds. And from there, it's easy. 3 parts is 60 pounds, and 4 parts is 80 pounds. And here's the same idea, but with a bar chart, which can make it really visual. Callan and Adam are sharing 240 pounds in a 5 to 3 ratio. Okay, so in total, that's 8 parts, or 8 blocks. You just divide the 240 pounds by those 8 blocks, and you find out each one is worth 30 pounds. So Callan gets 5 blocks, that's 150 pounds, while Adam gets his 3 blocks, which is 90 pounds. But here is a very, very common trap. Our brains are practically wired to see a ratio and a number and just immediately jump to that sharing method. But think back to our drink problem at the beginning. We don't have a total amount of drink to split. We only know the value of one of the parts, the cordial. And for that, we need a totally different technique. And that brings us to method 2, scaling. This is what you use when you know the value of one part. So remember our 1:4 ratio of cordial to water? We know our 1 part of cordial is 100 milliliters. So how do we get from 1 to 100? Well, we multiply by 100. That's our multiplier. And to keep the ratio balanced, we just do the exact same thing to the other side. So 4 parts of water times 100 is 400 milliliters. And now, for the final answer, 100 milliliters of cordial plus 400 milliliters of water gives us a grand total of 500 milliliters of the perfect drink. Simple as that. So, now that you've got these 2 core techniques in your toolkit, I'm telling you, you are going to start seeing them everywhere. This isn't just about drinks or money. Ratios are powering our world in some pretty surprising ways. Take cooking. A recipe says it serves 6 and needs 300 grams of beef, but you've got 8 people coming over for dinner. This is a classic scaling problem. First, you figure out the amount per person. 300 grams divided by 6 people is 50 grams each. Then you just scale it up. 50 grams times your 8 guests means you'll need 400 grams of beef. Done. Or what about a map? You know that scale you see in the corner, 1 to 50,000? That's just a massive ratio. It means that 1 centimeter on the piece of paper represents 50,000 centimeters in the real world. You do a quick conversion and you realize, wow, 1 centimeter on this map is equal to half a kilometer in reality. Ratios are literally the key to unlocking the real world from a flat piece of paper.
And, of course, shopping. To find the best value for your money, you use ratios to find the unit price. So that 4-pack of beans for £2.72, you just divide the price by the number of tins and find out it's 68p each. But hey, look at the bigger 9-pack, £6.39 divided by 9 is actually 71p per tin. So in this case, the smaller pack is the better deal. Ratios help you prove that bigger isn't always cheaper.
So, look at that. We've gone all the way from making a simple drink to scaling recipes and hunting for the best bargains. We've covered a lot of ground, so let's boil it all down to the essentials. Your personal ratio toolkit.
Okay, here's your big takeaway. At the end of the day, it all comes down to this. Ratios are for comparing things, and the order is absolutely critical. Always simplify them if you can, but most importantly, always ask yourself one question. Am I sharing a total amount, or am I scaling from one part I already know? If you're sharing, you add the parts and divide. If you're scaling, you find the multiplier and build everything else up. If you can get that right, you can solve any ratio problem thrown your way.
And to finish up, I'm going to leave you with one last little puzzle to really test your new skills. So Simon and Mark share sweets in a 3-to-7 ratio. We're told that Mark gets 8 more sweets than Simon. So the question is, how many sweets does Simon actually receive? Now this one's a little tricky. You don't have the total number of sweets, and you don't know either person's share to start with. The clue is in the difference. Look at the difference between the parts of the ratio, and then think about what that 8 more sweets really represents. You've got the tools. Happy problem solving.